My name is Ronen. I'm a developer at Wix. And welcome to my talk. Woo! OK, so this talk is going to be a live coding talk. I'm going to be something a bit different. I am going to show some things that are going. OK, we will be implementing some logic completely on top of the type system, which means we won't be running runtime code whatsoever. It's just types, the things you usually write on DTS files. The goal is to show you some capabilities of TypeScript's type system, show you how powerful it can be, sometimes a bit too powerful, and have some fun, learn some capabilities, and hopefully you can take this to some practical stuff as well. So let's begin. Other than this slide, I literally have 2 more slides. So most of it is live coding. OK, so let me just make sure this is big enough. OK, so I'm going to start. So our goal is to implement some somewhat complex logic, specifically on top of the type system. I will be starting with just a function. I think this isn't anything new to anyone. So I just have a very simple, this is big enough? I think so. So this is just a simple function. And this function can have an argument, for example, of type number. And this is, I don't think this is new to anyone. But this function essentially is something that runs, like this function is basically code that is going to run can run. Most of this part is code that can run. Other than this part, this is like a special part because this is a type annotation that I've wrote specifically for TypeScript, so the TypeScript can give me some diagnostics and things about my code. So for example, if I write foo and I pass something that isn't a number, like a Boolean, I would basically get this error. I hope you can see it. Other than that, I can also, and if I were to pass a number, then this would be OK. So this isn't anything new, but let's build on top of that. So I can also define the type separately. So I can define a type called R, which will be a number. And I can just reference R. I think this isn't new to anyone, but I'm basically just having my type, defining it as number, and having it reference here. And my type can be a bit more complex than just a number. It can also be a string, for example. In this case, my number can be 10. It can also be a string. But if I pass a Boolean, I would get an error. So this is nice. But my types, the type that I define doesn't necessarily have to be something general, like a number or a string. It can also be a more concrete value, like 10. In this case, this is the literal type of 10 that I'm asking. So even 11, you would get an error that it's incorrect. And you would have to pass specifically the number 10. We will be dealing a lot with very specific types in this example, as you will see in a bit. Other than that, one more concept I want to introduce before I continue is a concept that I think is somewhat misunderstood. It's generics. So generics in TypeScript, you define them with angle brackets like this, and you put a variable name in between. And I think this is a somewhat misunderstood concept, so I want to explain it a bit. So I want you to think of a generic essentially as a function, just like a function here, but on the type level. So if this is a function that would actually run, this is a function that can run, but on the type level. So I want us to implement a very simple function, a normal function, and then we will implement the equivalent on the type level. So let's do something like that. Let's have A be a Boolean. And I want to check if A is true. If it's true, I want to return yes. And otherwise, I want to return a nope. OK, so this is simple enough. I want to implement something similar on the type level. So this is this is something that we can really all understand what's going to happen. Like if I were to run this, assign it to a variable, TypeScript won't know which one it is, but I will need to run this. on the browser or Node, and I will know which one it is. But let's put this aside, and let's see if we can implement something similar on the type level. So I will implement foo. You'll notice that this is a convention I'm going to use by having types be started with capital letters. I will have a variable, essentially, for this function. I will call it A, and I want to limit it to only be Boolean. So I can do this by extend Boolean. This means that it will only accept types that extend from a Boolean. And if I wanted to do something like this, I can do it just as well, just like this with a ternary operation. So I can check if A extends true. If it is, I will return a yes. Otherwise, I will return a nope. So this is all the type level, and I can also run this type. So I can get my result of running this foo function by just using angular brackets. And if I were to pass something invalid, like a 10, I would get an error telling me that, hey, number doesn't match the constraint of a Boolean. But if I were to pass something like true, I can essentially run this code by just hovering the result, and you can see that I'm getting the yes. That actually ran behind the scenes. TypeScript ran it, essentially. I can also use a false and get the other result. So this is nice. We will build on top of this. We will write quite a few of those types. Let's put this all aside and get into our main objective. So the logic I would like us to implement is a sorting algorithm, a simple sorting algorithm. So I want it to look like this. I want us to be able to have the result. I want us to implement this sort generic, which would take an array of all sorts of random numbers, let's say something like that, and it would sort them. So the output for something like that would be 1, 3, 4, 5, 7, 7. So I want it to be something like that. Let's see if we can do this. So the first challenge I think would have to, that we will have, essentially, is that we will need a way to compare two numbers. We will need to be able to tell, hey, which one of those two numbers is bigger? Is 5 bigger than, is 7 bigger than 5? Now, if we were talking about normal JavaScript or TypeScript, we could have done, something like getting the result by checking, hey, is 7 bigger than 5, right? You guys telling me, hey, this is easy. So on the type level, I can put this aside. So on the type level, not so much. So you can't have a type which would do something like this. That won't even compile. Like, this is a syntax error. Types don't have support for this kind of math. In fact, they don't even have support for simple math. So even that is a syntax error. This doesn't exist on the type level, maybe for a good reason. So I want us to build something rather simple that will let us compare two numbers. So I want us to start with a very simple generic. I'm going to call it increment. So increment is basically, we'll be implementing the +1 function. So increment will take a number. I'll call it num. It will extend the number. And I'll just put this placeholder here. So I want this to be, essentially take a number and give us the number +1. So I'm going to do something extremely simple and check. Is num extend 0? 0 plus 1 is 1. Otherwise, does num extends 1? So 1 plus 1 is 2. Otherwise, does num extends 2? OK, that's 3. Otherwise, I'm too tired. Let's just have a 1 here, a -1. So just to recap, we're basically checking each option here is 0, 1, 2, and 3. And then I've got this is too much. And if something is basically too much for us to handle, we'll just return -1 as a way to symbolize that it's too much. Let's see if this stuff does work. It's not too complex, so I guess it would. So 1 plus 1 gives me 2. This is amazing. But I think this is nice, I think, but it's a bit hard to maintain, and I want to increase this limit a bit. So let's just maintain this in a somewhat more maintainable way. I will have a type. I will call it increment table, which will just be a type. And this type will have its keys mapped to the will have keys as numbers, which will map to values, which is the result. So 0 maps to 1. Because 0 plus 1 is 1, and 1 is 2, and 2 is 3, and 3 is 4. I'll just go all the way up to 10. That would be enough. 5 is 6, 6 is 7, 7 is 8, 8 is 9, and 9 is 10. Okay, and then, so basically this is just a way for us to map those. And I can now basically remove all this shit. I shouldn't say shit. And I can check if the num that we have, this is the type argument, is I want to check if it's any one of those keys. So I can check if num extends key of increment table. If it does, so this is basically telling me, hey, is num one of those values on the left? I can just access it by accessing the value. Okay, otherwise we'll return -1. Now basically let's see if it works. I can hover result, 1 plus 1 is 2, 5 plus 1 is 6, and 11 plus 1 is too much. Now, there are more sophisticated ways to do this in ways which won't have you like be limited to a certain, like a size that's small. But I think that's going to be enough for this demonstration. If you want, let me know and I will give you some info on this. Other than that, we have a way to increase a number by 1. We still don't have a way to compare two numbers. That was our initial goal. So I think, but we will definitely be using this. So next I want us to define the greater than method, which will essentially take two numbers, an A and a B. Both should be numbers. And let's just have a placeholder here. So I want it to basically return true if A is bigger than B and false otherwise. Anyone has any idea on how this can be achieved? Okay, so I have a rather simplistic idea. So what I want to check, I'm going to assume both of those numbers are anywhere on the increment table, that they are of normal size, and I'm going to increase both of them by 1. And then I'm going to check which one went off bounds. If none of them, I'll keep increasing them 1 by 1 by 1 by 1 until the first one goes into -1, and then this one is bigger. Okay? I will also mention that there isn't really a way there is no loops, there is no while, no for loops, no nothing. The only way to actually do iteration on the type level is with recursion. So brace yourselves, we'll be writing quite a few of those. I like to write my recursions by starting with the exit clause. So we can essentially take a check. I'll start with B. So we are checking if A is greater than B. So I'll first check if B went off bounds. So if B extends -1, so if B is bigger, essentially, it went over faster, then it means that A isn't bigger, so it's false. Otherwise, is A off bounds too large, will return true. This is, again, we're checking if A is greater than B. Otherwise, I'll just put a placeholder so that we can format this. Otherwise, we want to recurse by increasing both numbers and check again. So we'll just run the recursion. Greater than, we will increment A, and we will increment B. Okay, let's see if this actually works. So I can get the result by having greater than, is 3 greater than 6? No, good. Is 5 greater than 6? No, good. Is 6 greater than 6? Should be a no, it's not. But is 8? Yes. Amazing. Ooh. Okay. Now, before we continue sorting, I want to have another utility which we will be using. I want to implement a small utility which I will call tail. So I want tail essentially to do the following. I want it to take an array. So let's say, for example, I have this array, and I want it to basically return the same array just without the first element. Okay, so for this array, it should just be something like this. It's a very useful utility. We will be using it quite a bit. So it just drops the first element of the array. This is going to take an array. This can be an array of anything. I don't care. And then we'll start by just checking first the check. Okay, so we will just be checking if the array extends. So we want to check if this array has at least one element because we want to drop that. So we'll check something like that. We'll check if the array extends another array, which I don't care about the first element. What I do care, I want the rest. I want everything but the first element. So I can use a special syntax by using infer rest. So let me explain what's going on here. I'm checking if array is an array with at least one element, which I don't care about. If it is, I'm just telling TypeScript, hey, assign all of everything else, everything but the first element into this variable, which I can use now. If I cared about the first element, I can also use infer and give it a name. And now I can use it. This is the first element. I can do it the same for the next element. And you don't necessarily have to do this with just arrays. You can do it with anything. In our case, I don't care about the first element, just about the rest. And then if this is the case, I want to return the rest. So I just drop the first element. Otherwise, I will just return an empty array. So an empty array, the otherwise clause can actually happen if this array doesn't even have one element. It's not critical to understand the exactly what happened here. What's important in this case is result is to see that it actually works okay. So I can check this by running tail with 1, 2, 3, for example. And if I hover this, it gave me just a 2 and a 3, so it dropped the 1. If I just add a 1, this should be an empty array. And if I had an empty array, it should also return an empty array. So it's a useful utility. Okay, cool. Okay, so back to sorting. So I want us to implement some sorting. We can already compare two numbers. So pretty much the rest that we need to do is write some sorting. So I want us to write the following function. I will call it insert. So insert will work this way. So it will take a number, and it will take an array of numbers. Let's just have a placeholder. And I want it to essentially put the number. So we can assume that this array is already sorted. So this function assumes that this array that it got is already sorted, and it needs to put the number on the right place in the array. So let's think this through. So essentially, as a rough example, let's say we have the number 3 that we want to add to the array of 1, 2, and 4. So the result should be 1, 2, 3, and 4. Okay, this array we can assume is already sorted. Let's see how we want to tackle that. Let's think of some edge cases. So option 1, let's say I want to insert 3 into an empty array. This is rather easy. I just want to have 3. There is no other option. I have this case, in which case I need to put the number somewhere in between the array. And I think there is also the more simple case of having 3, for example, in having 0, inserting it into a 1, 2, and 4, which in this case, the 0 goes before the entire array. Okay? Okay, so let's get to it. So we can start with an empty array. So I can check if the array is an empty array. In this case, it is rather easy. We just want to return the array with just a single number. This is this case. Otherwise, let me just put a placeholder so it formats. Okay, so next, so let's put this up top. So for both of these cases, I need to compare the number that we currently have with the first number. I want to compare it with the first number because the array is already sorted. So I can check I can use greater than, and I want to check if my number is greater than the first element. The first element on the type level is rather easy. We have the array. I just need to take the array on the 0th place. Okay, so I can check if this extends true. So we check if, hey, is our number bigger than this? Let's just have 2 placeholders so we can see it clearly. So I think I want actually to start with this clause. So this is the case where our number is smaller than is not actually bigger than the. So I want us to check this clause first. So in which case our number is actually equal or smaller than the first number. In this case, we just want to put it first, right? So that is rather easy. We just have a new array. We want to have our number. And then we just want to spread the array. This case is a bit more complex. So this is the case when we actually have the number. We want to put it somewhere in between. So we need to check the next number. We need to recurse. So the way that I'm going to tackle that is by returning a new array. We already checked the first element, and we know that the first element is smaller than our number. So we can already go ahead and put, this is the first element which we compared. We can just put it here on the result. We can just place it. And we now want to check the rest of the array. So we compared 3 and 1. Now we want to check the rest of the array, which is something we have tail for. So I will just go ahead and run insert again by recursing. The number stays the same. And for the array, I will just tail the array. I want to check the rest of the array. I think this is it. Let's check. Oh, I forgot to spread this. Yes, thank you very much. OK, so let's check. So I should be able to run insert. Let's actually start with the simpler edge cases. So let's insert 3 into an empty array. So that should be just an array with 3. This is nice. Let's have 3, for example, into a 4, 5, and 6. This is the second case. 3, 4, 5, and 6. This is nice. And let's check if the recursion actually works. So let's have 3 into 1, 2, and 4, like we did before. 1, 2, 3, 4. Amazing. Woo. OK, this is nice, but let's finish this up. So finally, I want, actually not entirely finally, but I want to actually implement the sort function that we started with. Let me put it up top. So what I want this to do is something like this. This is how I want to tackle it. We can remove this. So sort will take an array of numbers, extends a numbers array. I'll just have a placeholder. So this is how I want to tackle it. I want to have an internal variable to keep track of a result. I will call it ACC, as in short for accumulator. And this is going to also be a numbers array. And I will initialize it into an empty array. So I don't expect anyone to actually pass this. I just use this as a way to keep track of internally, of some internal state. And this is how I want to tackle that. So assuming we have this array initially, so we'll have the accumulator as an empty array. I hope everyone can see this. Yeah, it's pretty big. OK. So I want basically to take the first element. This is a really simple function. We will just be taking the first element, and we will use insert to insert it, to remove it from here, and insert it into the accumulator on the right place. Remember, inserts those everything in the correct place. Then we'll take the next number. Let's actually do this like every step of the way. So that will basically be taking 3 and putting it on the right place. The next time this runs, we will be taking 6, and again putting it in a sorted way. Then we'll be taking the 1, putting it in a sorted way, and then when this thing is empty, we can just return the result. Okay, so it's simple enough. So let's start by when the function terminates. So I can check if array is an empty array. This is something we already know how to do. We'll just return the accumulator. Otherwise, what we want to do is just recurse. So we can run sort again. We want to run sort, as you can see, every time I do this for everything but the first element. So we can use tail or tailing the array. And as far as the accumulator, I want to insert, like we planned, the first number that I'm currently handling, for example, this 3. So this is just ACC on the first place. Not ACC, I'm sorry, ARR. Yes, and the array itself is the accumulator. I just want to insert it into the accumulator. Do you think it's going to work? I've had some bugs before in live coding, so don't be so sure. Blah, 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 blah. And let's see if it gets sorted. Amazing. Woo! OK, so like they told me to stop here, but let's give it one more push. So for like the talk basically finished here, but let's give it one more push because why not? If I were to increase the size of this input a little bit, I don't need to even do this too much. Maybe one more. OK, yes. This is an error maybe some of you have experienced if you tried to do stuff like this before. So maybe some of you actually encountered this stuff before. I've fought with it relentlessly. This is type instantiation is excessively deep and possibly infinite. The problem is basically, which we wrote, not very efficient code. So in languages where recursion is the way, and here recursion is the way, there is often an optimization where you can write your recursions in a way which is called tail call recursion. I will show you how this is written in a moment, but if you do write your recursions in a certain way, in a tail call way, it really depends on the platform, but the platform may be able to optimize your recursions. So this is something that is basically depending on whichever platform actually runs your code. For example, you can write tail call recursions in JavaScript. No one will optimize them, so it's basically the same as not writing them this way. Luckily enough, recently, TypeScript added tail call optimization support for the type system, which means that you can write tail call recursions in TypeScript, and TypeScript will optimize it. So let me explain what is a tail call recursion. So a tail call recursion is, for example, is this sort function, for example. So a tail call function is a function that whenever it recurses, it doesn't do anything with its value. It just returns it, and that's it. Okay, so you can see sort, for example, the one place where it recurses it's here. It's just returning this value. It doesn't do anything with its, it doesn't do anything with its value. It doesn't manipulate. It doesn't care about the value. You can see, for example, that insert, on the other hand, is not a tail call recursion, because what happens is that on the one place where we recurse is here, and we basically spread the result into and create a new array out of it. This is a big no-no. If you can, like not every recursion can actually be optimized. This one can. The problem for those, like if you want to understand, essentially what happens is that, and this is not specific to TypeScript at all, but the problem is that in this case it's TypeScript, but TypeScript has to remember to come back. If I were to have like a very big computation, TypeScript can just calculate it outright. Okay, so if I had a comment here, this, let's zoom into the insert function. So in this case of recursion, we would put a number here, and then we would spread everything else. And then we would put a number, and we would spread everything else. And we would put a number, and we would spread everything else. And if we have a really long expression, this is a very big list that the compiler needs to hold in memory. If you use tail calls, the compiler doesn't need to remember to go back and do any. It doesn't need to care about the result, and it can essentially optimize its memory. What I want us to do is to essentially refactor insert to actually be tail call. And often when you do this, you use an accumulator. So I'll just have an accumulator, which is going to be a numbers array, just like here, and I will initialize it to an empty array. Okay, just prettier formatting my code. So let's just adjust each of those cases. And also, let's just figure this out here. So for example, I think the one complex example is, let me just remove those, is this one. So the way that I want this to be with an accumulator, so let's see. So we want to insert 3 into a 1, 2, and 4, and this is the accumulator. So what I want to do is essentially whenever we take a number, if our number is bigger than this number, I want to take this number and put it here, and then I want to take this number and put it here, and eventually when we get a number which is bigger than the 3, we can create a new array by having 1, 2, 3, and 4. So in the case where the array is actually empty, I would need to spread over the accumulator. This is the case where we basically insert the 3, let's say we had no 4. So in this case, we would essentially take, this is the accumulator, this is the 3. We just create the array here. Let's handle this case as well. We just want to have the accumulator, before, right between our two numbers, before our number. And let's go ahead and take this recursion and just flip this thing into being part of the accumulator. So we essentially want to just take the entire accumulator and just put the first element, right, up here. So I think that should do it. you can see that the squiggly is gone, and our sort function should be able to tackle this no problem, unless I made. No, that should be okay. I think I messed something up. Let me check. Completely messed something up. Let me see. I think I need. No, I think it's good. I'm not sure what went wrong here. Okay, so I think the recursion is fine. I will be done in no time. So let's just have a new input here. It's not a all good, all good. So let's see that this actually sorts. Fine. Yes, and if we were to increase the size, let's just increase it a few times over. It should be able to deal with this no problem. We actually have a 56 here, which I don't want to have. I can even increase this a few times over, and this should be fine. This isn't VS Code, unfortunately, but it should be okay. So this is like a really big number. And yeah, there is still an internal limit in TypeScript, so you won't be able to do infinite stuff, but you can do stuff a lot more stuff. So these are a few projects, if you're interested, that do a good job at expanding on some of this stuff. Also, I hope you learned something. Like you normally shouldn't do this kind of stuff, but a lot of popular. Sometimes you do need to write recursive types. Some libraries make use of them. I think Zod makes use of them. It's useful to understand them. On some cases, they are useful. And hopefully you learn some stuff that you can do with the type system and enjoy this live coding talk.